Righto, time for a tricky differentiation question. So the question says the graph of y equals ax cubed plus bx squared plus cx plus d touches this line, which looks like a linear line, 3y minus 3x equals 43 at the point x equals negative 2. It has an intercept at 0, 3 and a stationary point at 2 and 11 on 3. Find the values of a, b, c and d. When I first look at a question like this, what you got to do is you got to think about conceptually what's going on. So you've got some graph, maybe looks something like this. That's bad axes, but it goes to cubic, so maybe it goes something like this. And we know all this information about it. It has a stationary point, maybe it's this one here. At 2, 11 on 3, it has an intercept at 0, 3, so maybe that's there. And then there's some other line that tangents to it at x equals negative 2. Something like that. So it's good to get an overall picture of what's going on, and then hopefully we can take out the little bits of information that we need to solve the problem. So the first piece of information says it has an intercept at 0, 3. So that means when my y value is 3, my x value is 0. So let's see what that gives us. Subbing a y value of 3 into this original equation here gives me 3 equals, well, it's going to be a times 0 cubed plus b times 0 squared plus c times 0 plus d. Hopefully you realize that all those things cancel out, all the zeros there cancel out, and then we get our first answer, which is d equals 3, which is handy. So we can put that to one side for now, and we can use that even in what we do next. Alright, the next thing we can do, it says it has a stationary point at 2, 11 on 3. So that means in our original graph, that's just a coordinate point, isn't it? So it says when my y value is 11 on 3, my x value is 2. So that can be used to give us one equation. And as we can see, we've got to find these a, b, c, and d. And usually when you see something like that, it's going to turn out to be simultaneous equations. So just with this first part here, we're going to substitute in 11 on 3 for our y value. Alright, when my y value is 11 on 3, my x value is 2, so it's 2 cubed plus b times 2 squared plus c times 2 plus, well, we know d now, we know d is 3, so we can write d as 3 in there. Alright, 11 on 3 equals 8a plus 4b plus 2c plus 3. Righto, that'll be our first simultaneous equation. What other information do we know? We know that it has a stationary point. Well, a stationary point is where the derivative equals 0. So we know that when x equals 2, our derivative is going to equal 0 because it's a stationary point. So we can say, first of all, we can find the derivative. So y dash is equal to 3ax squared plus 2bx plus c. And then we can say, alright, our derivative is going to equal 0 when x equals 2. So that's going to be substituting in 2. So it's 3a times 2 squared plus 2 times b times 2 plus c. That's going to give us 2 squared is 4. 4 times 3 is 12a plus 4b plus c. All that equals 0. Awesome, there's another piece of information we've got. So we've got 2 equations now, and we've got 3 unknowns, so we need one more piece of information. So that's going to come from this part here. This is a linear line, but it hasn't been written in the form that we like. So what we would like it to look like is if it was arranged such that y was the subject. So let's see if we can do that. So 3y is going to equal 36x minus 43, just adding 36x to both sides, and then we're dividing by everything by 3. So that's going to be 36 divided by 3 is 12x minus 43 on 3. Good. So what we're going to do now is we're going to set those two things equal to each other, because we know when this line, we know that this line here, or this line here, which we've just rewritten, is equal to our graph, our original graph at the point x equals -2, so we can set them equal to each other. So we can say, give myself some space, we can say 12x, let me just block that off, say 12x minus 43 on 3 is equal to our original graph, which is ax cubed plus bx squared plus cx plus d. Well, we know d is 3, don't we? Alright, and then we also know that these lines are equal when x equals -2, so we can substitute in -2 wherever we see an x. So that's going to be a, I'll see if I can do a shortcut here, so that'd be -2 cubed is -8a. -2 squared is +4, so that's plus 4b minus 2c plus 3. Alright, that will be our third equation. I'll just simplify actually the left hand side here a little bit. -12 times -2 is -24. Minus 43 on 3 equals -8a plus 4b minus 2c plus 3. Easy. So we'll just say, even though it's not very nice in a nice form, we could simplify the left hand side and maybe bring the 3 over, but we're just going to say that's our third equation. So now we've got 3 equations with 3 unknowns, and I did this before, and I haven't got like a app for the CAS on here, so you're gonna have to take my word for it that if you put those three system of equations into your CAS and solve for a, b, and c, you will get a equals 1/3, b equals -3 on 2, c equals 2, and d equals 3. Well, we knew d equals 3 from the start. So those are our answers. You can check that by substituting those values back into your original equation. So you substitute your a, b, c, and your d values in, and then you can see that it satisfies all these conditions. This line touches it at x equals -2, it has an intercept at 0, 3, and has a stationary point at 2, 11 on 3, which I think is pretty nifty. Alrighty, that's it.